My name is Chris Griffiths. I am Director of Royal Museums Yacht Club Maritime Sustainability Programme. Thank you, and you're all welcome, guests as well. So Paddy Rodgers, our speaker, has had an illustrious career in shipping. You ended up as CEO of Euronav,
That's right.
big shipping company.
It was the largest publicly traded tanker company in the world when I left. 75 what you'd call super tankers, about 10 million tonnes of shipping.
Right, that's a good start. Then you retired, and so Paddy now is director of the National Maritime Museum at Greenwich, which includes the Cutty Sark, okay, which Thames members will know because we're having at least one event on the Cutty Sark in our 250th anniversary year next year. So I will keep quiet and hand over to Paddy.
Thank you very much, Chris.
Thank you.
Yes, so I had three careers really. I was a lawyer initially, and then of course was involved with Euronav and ran it for 19 years, and then moved on to the museum afterwards. You know, as my father used to say, when one door closes, another door opens. Lovely bloke, terrible cabinet maker. So, the Cutty Sark, Houdini of the sea, the one that got away. The reason that I chose that title is because I think that there's this fascination, which was a bit of an historical fiction, that she was the fastest ship. She was certainly very fast. But the key to her is, for us, if we're going to understand the significance of her, is not so much the fact that she might have been fast, as all clippers were, but really the fact that she survived. And we've been very, very lucky because she is the one that got away. Clippers, it was like driving a Lamborghini without a clutch. I mean, these things were at the edge. And whilst the fatality rate on board these ships was not high, I mean, there were murders on the Cutty Sark, there were deaths through sailing accidents and various other calamities. But generally speaking, this wasn't as dangerous a lifestyle as you might imagine if you ever climbed the rigging and looked down and imagined being in, you know, roaring seas. The reality of it was, though, that White Hat Willis, who owned this ship, had a fleet of 28, 14 of which ended up sunk. So that's where the real danger was, in the total wipeout. And of course, a lot of these ships didn't last. And you'll see, as we go through some of the slides, a little bit of that history. First of all, there's a maxim from the shipping industry, which is that ships don't move cargo. Cargo moves ships. So what does that mean? It means this, that the only reason that you have a Royal Navy is to protect the Merchant Navy. And the only reason you have a Merchant Navy is to make money by transporting cargo. And what does cargo transportation do? Well, for land-based species like ours, you have local single markets defined by what's easy to reach within your area, and what's in demand, and what's available as supply. But of course, in other places linked by the sea, you'll have exactly the same thing. Things that are in supply, things that are in great demand. And in between the two, if you get to the point where goods go in oversupply in one country, to the point where the price drops, and they go into shortage in another country, and the price rises, you will open up what's known as an arbitrage, a difference in pricing between one where it's cheap and the other where it's expensive. And when the arbitrage is greater than the cost of transport, the markets become geographically united through shipping, because ship owners will go and collect a cargo there and deliver it here. In the old days, it used to be the ship owner. In more modern days, it would be the trader. And that's essentially what's driving trade around the world. And the only time that really changes is when you have government intervention with a deliberate intention to grow an area or to oversupply a particular area. So, the bigger the art, the quicker the move. Right? So the more money that you can make by making that transfer, the quicker you want to do it, because you can go back and load another cargo before the arb closes. And then it's a straight race. Because as long as the arbitrage is there, every ship will try and make that trade in order to profit from the arb. So the bigger the arb, the faster you go. And that's where clippers come in. So the point of a clipper was to have maximum sales, maximum cargo, and minimize everything else. The term clipper comes from an American term, to go at a clip, because they went quickly. The first time these ships were developed into something much bigger than the Cutty Sark, starting with the American War, the Second American War of Independence against the British, when they evaded blockade. So they were able to charge a lot for the goods they brought in because so few ships were fast enough to beat the British blockade. When they'd finished that trade, they were looking for other fast trades to be involved in. One of those was the trade in opium out to China, where you could buy tea to bring back. And the reason you wanted to be quick then was that you had to evade Chinese customs officials, and you had to be able to avoid being seized for carrying opium. But if you could get up the river, you could drop your opium, collect silver from the opium dealers, and then with the silver go and buy tea in Canton and bring it home. So it was a double freight, which is fantastic for shipping. You get paid on both legs, and you get paid well on both legs. Slightly contraband element. This ended with the Opium Wars, when China's restriction on foreign trade was broken, and as a result of which normal trades took over, and there could be a barter. The Chinese originally had insisted that tea could only be sold for silver because they needed the specie, they needed the currency in the country to keep liquidity in the economy. So the only export that they had that people really wanted in volume was tea. They wanted silver in return. The only thing that we could sell to them that would guarantee silver to balance the trade was opium, and that was a contraband cargo. So that's how the system worked. But once the trade barrier had been lifted and trade could flow freely, then there was no need to take opium. You could take other goods that the Chinese wanted to buy, and the trade balanced. But what of the clipper that was left over? Well, the clipper almost walked straight into the Californian gold rush. And so the only way to go from the east coast of the USA, where all the things were that a miner might want to buy, and the west coast, where all the gold was that you might want to get paid in, was an enormous sea voyage away. And so clippers, again, came back into their own, and they ran that trade for another decade. So that was the 59ers running through to 1860s. And the reason that it stopped was simply because a railway was built in Panama, and then paddle steamers could go down the east coast, reliable, certain in their arrival times and destination, to match up with a train that would take the goods over the Panama Isthmus before the canal was built, and then up the other side in a paddle steamer as well. And the day of the clipper looked over. The tea trade was still running. The Cutty Sark was built by White Hat Willis. Well, I'm going to give you another truism about the shipping industry, which is the most important feature of a ship is its price. So if you imagine that in any given period of time you can imagine a state of world economy and a state of world transport as a result of the world economy, and you can imagine that it might be good, it might be bad, it might be indifferent, but any two ships that live through that period of time will have the same gross earnings. The difference between somebody who might make a profit and somebody who might make a loss is the price they paid to enter the trade. And of course, if you pay a low price, you're always making a profit. If you pay a high price, you might make a profit, but it will be a less significant one. White Hat Willis had the genius idea of buying from the government, and there's a surprise that the government might do a bad deal on the sale of an asset, two of their steamships that were used as gunships in the first Afghan war. And he bought them both. He sold one of them for the same price he'd bought both of them. And he converted one of the steamships into the Tweed by stripping out its steam engine and putting in sails. And it made his first and most successful clipper. He always said it was the ship he loved the most. And of course he did, because he actually got paid to own the ship. The ship was fantastic in trade because it was cheap, but it also had great lines. And it was like the lines of that ship, the Tweed, which hadn't been built as a clipper, which were used for the Cutty Sark. But they were good and they were smooth, and they were good enough for the clipper, for the Cutty Sark to be designed on them. The Cutty Sark had competition. This is the SS Great Britain. It's a time of dual fuel. So 1870, he's building a ship which is the drawings have been designed by Hercules Lintott, and they're built up on at Greenock in Scotland. he manages to negotiate so hard the shipyard went bankrupt. But he got the ship finished and he brought it down, determined to run it in the tea trade, which was still thriving but didn't have an opium back cargo. The cargo that you took out to China was either taken to Australia or taken to Hong Kong or other British possessions, usually furniture and things that people wanted for their homes, and then up to China and then back home with tea. And he was pretty certain he was going to make a fortune. But unfortunately for him, they finished the Suez Canal in the year that the ship was delivered, in 1870. And the Suez Canal was a killer. And it was a killer for two reasons. The first reason was that it absolutely obstructed his trade, because his competitors who ran steam engines could use the Suez Canal and could cut 3,000 miles off their voyage, whereas he had to go around Cape of Good Hope and had a much longer voyage to perform. But secondly, the Worms Company, once the Suez Canal was established, started putting bunkering stations all the way through the Mediterranean, through the Suez Canal, and then out the other side into the Near East. And then from that, further and further out. And so we started to get a distribution of coal and clean water that were critical for making a steam engine work. The biggest problem for steam engines initially was they couldn't be guaranteed those two things. So then the Cutty Sark, these steamers got a competitive advantage through the Suez Canal, and they also got an additional competitive advantage through advances in steel production. And steel production, because quality steel was produced for the first time, proper steel production, it meant that you could increase boiler pressures. Once you could increase boiler pressures, then these steam engines became really effective and began to be a proper competitor for a sailing ship. The Cutty Sark on its fastest voyages would be doing about 17 knots. Most commercial shipping that's in the bulk trades or in the tramping trades is probably doing somewhere around 13, 14, 15 knots today. So unless you're in high value cargoes, you're not really seeing an outperformance on the ships of the 19th century. So under the cosh, but doing reasonably well, and 20 years in the trade before it was sold to Portuguese owners. Steam and sail. 1820, we put the first steam engines on ships, and one of the first places it was done was on Deptford Creek at the factories of William Penn, and then those ships were used primarily for handling ships, for helping to move ships around the river. Once you got close to land, of course, as all sailors know, is the point when you're at the greatest risk. And at that point, sailing ships are at particular risk and have less control. But if they could get into, if they could be handled by a tug, then of course they had a slight advantage. And that's how the tugs were developed on the river. 1820, and then the last of the sailing ships performing grain cargoes or agricultural cargoes out of Australia at the end of the Second World War. And you might wonder, how could it be that sailing managed to stay in touch with more modern fuels through all that period, 120 years? And I've said there were some inefficiencies around steam, but by the time we get to 46, we're talking about most of the a lot of the ships in the world being oil-powered, diesel, oil-fired engines anyway. You can certainly see one thing, an economy of scale. So the ships moved right up. This is I think this is one of the P-class ships of the light fleet. Eventually Ericsson owned them at the end of the Ireland Finn. Ericsson owned them at the end of the Second World War. And if you've ever read Eric Newby's The Last Grain Race, it was on this type of ship. His steel hull, steel masts, pretty much everything was steel apart from the sails, and the ship's much bigger than the Cutty Sark. So the Cutty Sark would be about 750 tons of cargo, and this would be about 5,000. One of the things about the Cutty Sark that's important, I showed you a picture of the SS Great Britain, a hybrid ship using steam and sail. The Cutty Sark was also a hybrid ship because it used a wrought iron frame. So although it's made of wood, its external surfaces are wood. Inside, instead of having big, heavy beams to give it its stability and strength and its shape, it uses raw time. The big advantage of that is that it's much thinner. The scantlings are much less than they are with a wooden beam ship, and it means you can carry more cargo. So it just keeps coming back to this theme. When these ships went down to Australia at the end of the Second World War, all the way through the 30s and the 40s and the 50s, 30s and the 40s, why is it they could compete? Well, one of the things was that they could take their time going down there. When they arrived, they went to outstations, farms that are far away from any infrastructure. If you had gone down there with a conventional engine, your problem would be, where am I going to get oil? Where do I rebunker? And these guys didn't have to worry about that because the wind is free. They could just go down there, wait for the winds, and they could take their time and they could gradually load their agricultural cargo. And then when it was the right season, they could come back. And it cost nothing other than the cost of the crew and the cost of the investment in the ship. But by this stage, these ships are stranded assets. They don't really have any value, and certainly people like Ericsson could pick them up very cheaply. So they're really running a sort of nil loss or nil possible loss trade and picking up the odd cargo, delivering it effectively and making a fortune. The question, Whitehat Willis said that, that the wind was free, so why would he pay for a steam engine? And I wondered whether it was, because I looked at the crew lists of the Cutty Sark, and I thought, well, why don't I just run down the rankings that you might have on either a modern tanker or on a sail ship. Run down the 1870 pay down here of the crews on board the Cutty Sark, and then have each as a percentage of total, and then do the same with a modern ship. So you'll see very different screwing. So no engine room staff in the sail ship, but of course they have a whole rank. ABs are very important. Carpenter and sailmaker are part of the engine room. Why is this of interest to us? Well, only this, that in terms of the balance of a crew, the sailing staff in an 1870 ship was 45% of the crew cost. And in the engine room staff on a modern tanker is 46% of the cost of the crew. So things don't change that much. The big difference, of course, this ship had a problem with intermittency. It could be unreliable. If the wind didn't blow, or if the seas were too rough, it could be late. It won't never come, but you couldn't be certain. Whereas this ship is absolutely reliable within degrees. But the thing that's not counted here is the cost of fuel. So this is what a big ship looks like. These are ULCCs, and the total length of the ship is about 380 metres, 60 metres in beam, and carries 440,000 tonnes of cargo. Remember, the Cutty Sark carried 750 tonnes of cargo. But this ship will burn at least 100 tonnes of fuel a day. That means that that ship will produce 300 tonnes of CO2 a day. The question we'd have to ask ourselves, whether we go back to the SS Great Britain or whether all the way through to looking at this ship, is that we never looked at the impact that we might have through the emission of carbon into the atmosphere. People were very aware of the impact you might have on a local basis, and there were many complaints in harbours and ports of householders hanging up their washing and then complaining that soot was blown by the wind across their washing, or that it was a dirty trade, or that it was making things worse. But remember what London looked at the time, with everybody on coal fires. People were used to soot and dirt, and pollution was a localised issue. Didn't impact the countryside. But if we look at ice cores from the from the Arctic, what we can see from them, and from the Antarctic, is that we start to get real impact of carbon deposited within the ice cores around the time that we can see a little bit before the Cutty Sark arriving. So we know then that the impact that carbon's beginning to have on the whole atmosphere of the Earth is becoming completely global and widespread. And it's not long before the breakdown is not going to be local, it's going to be systemic. But this is never counted. The damage that's done is never put against this. And what you see here is the archetype of an economy of scale. I was saying earlier on, you're trying to maximise cargo, and you're trying to maximise cargo, and you're trying to maximise your speed or your reliability. This is the ultimate statement of maximising cargo. But it's not very pretty. Taller than the Eiffel Tower. This is not actually one of those ULCCs, this is a standard VLCC. Taller than the Eiffel Tower if put on its end, could carry the equivalent of 5.6 million kegs of beer, and its depth from its castle here to its keel here is higher than Harrods. So you can get a sense of the ship being quite enormous, and quite a different order of scale, different from the Cutty Sark. Two things are apparent about it. One, of course, is that huge economy of scale. The other is the fact that it is a huge emitter of carbon. But also, you can see that there is absolutely no focus on the lines of the ship. The ship has been boxed out as much as possible to make it as cargo efficient as possible. And I'll come back to that a little bit later. What happened to the Cutty Sark? When a modern ship goes through a period when freight's very low, so your income's very low, but your cost of fuel is very high. And just to go back to the example, and I know Dennis is in it, he could probably tell me what's a ton of fuel cost today, Dennis?
to buy, it's $600.
So at $600,
Ripping me off.
at $600 a ton and 100 tons of burning a day, a big ship is burning $60,000 a day. So very quickly you can see it's absolutely critical how much you spend on your fuel. When the market's bad, you could be in a situation where you don't get much more than $60,000 or $70,000 a day, and you're burning $60,000 a day. So what you do is slow down. And the reason you slow down is that when you slow down, you save fuel, and you can save yourself into a profit. And one of the reasons is that I think it's the Froude effect, which sailors you're probably all familiar with, and it's that there's a linear relationship between fuel consumption and speed on these hull forms to about 12 knots. But once you go above 12 knots, then it becomes a cubic expression. So the differential between going 15 knots in a big ship and going 11 to 12 is very, very significant. You could shift from 100 to a little bit over 50 just by dropping your speed. We call it slow steaming, and it's an economy of a poor market. So what does the Cutty Sark do in a poor market? I told you she was sold. She went from high value trades, where she was being paid a lot for making these tea runs, and then eventually making agricultural produce runs from Australia. And to say how fast she was, the fastest voyage she made from Australia to London was 67 days. That is really, really impressive, and impressive by any modern ship standard. She was sold Portuguese, and when the Portuguese bought her, they used her in a trade from Mozambique to Angola, carrying coal. Nobody much cared about speed. It was a dirty business. Essentially, it was a state-to-state business to ensure that there was a sufficient supply of coal to Angola being delivered from Mozambique. I mean, of course, these days it's totally ironic to us on the basis that Angola was sitting on enormous reserves of crude oil. But that wasn't known at the
A
time.
lot of other things as well.
So how do you slow steam? At this point, nobody cares whether you get there one day or the next. So instead of going 17 knots with a dirty cargo of coal, they're happy to go pretty much any speed. So this is their version of slow steaming. You'll no longer see the full mast array. You'll now see that her third mast is no longer a square mast. It's now, in fact, her only square mast is going to be her foremast. The other two will both be in the yacht style to make this a barkentine rather than a clipper. Now she's going to do 9 knots at best, but very importantly, the crew can be taken down from 28 to about 15. So you get your fuel saving by having less people on board. The ship got given a pretty hard time, and in 1922 she came into Falmouth looking like this. And this guy, Captain Dolman, was married to this member of the Courtauld family. The couple had met on a cruise, and he had married her on a cruise, and they both had a good eye. She had money as well, which is very important for restoring historic ships. But he spotted the diamond in a rough. And so they did this and restored the ship. This is a really important moment for the Cutty Sark, because in all, what happened to most of the other clippers was they'd have ended up in someone's oven, chopped up for firewood. But this one gets fully restored and is used as a training ship, eventually coming to Greenwich. And again, post Second World War, most people thinking, do we really need these ships? And here we are, another race run, because this was a competitor of hers, because this was another training hull that was down at Greenwich, the Implacable, a French ship that was taken by the British during the Napoleonic Wars, and then repurposed and used in British service for a long time. She ended up at Greenwich, and it was decided that she was too expensive, so she was scuttled. Before she was scuttled, the rear detailing that you see here was rescued from her, so there would be a memento. But there was a massive public outcry that we were damaging our heritage and forgetting our past. And so that really stimulated the Royal Rescue. Prince Philip took charge of the trust fund. This is them bringing in the Cutty Sark to Greenwich. Those of you that know Greenwich will see that that's the foot tunnel at the back behind it. And this guy, Sterling, was a cadet on the Cutty Sark when she was under British flag in the 1890s. And there he is in the 1950s watching her coming into Greenwich. That's absolutely wonderful moment. And then of course, with its royal patronage, she has a completely different status and has been saved for the nation, and more importantly, saved for us as a memento and a thought provocation as to what we're doing with our futures. Of course, she had a very famous yet another near miss, and in 2007 she was being re-rigged, so all the rigging and deck fittings had gone and most of the weather deck. So most of what you're seeing on fire there is the cover that was put over the ship for the repairs that were to be done. And the reason for the fire was that somebody had left a fan on overnight and it shorted out and then set fire. So a huge amount of charring on the ship and quite a lot of burnt wood, but none of the wood belonged to the Cutty Sark. So I'm proud to say that she is still substantially the ship that she should have been. The great Houdini. She didn't get burnt out, she got saved. But in '69, she was very nearly not built at all when the shipyard went bankrupt. In 1872, when she was competing against the Thermopylae in the race back from China, she lost her rudder. I just have to say a word for the kind of people that you have on board a ship like that they jury-rigged the rudder, including forging new hinges for it, at sea with a brazier. One of the men burned, not insignificantly as a result of the brazier tipping during the forging, and they lost something like 2 days. This was done off the coast of West Africa with no support vessels, nothing to give them stability. It's a remarkable act of seamanship. In 1877, she lost an anchor. In 1885, she breaches in the Southern Ocean, turning on to a massive wave, and yet survives it. In 1891, she met the 100-foot wave and survived it. In 1906, under Portuguese ownership, she's in a hurricane off Florida and survives it. And in 1915, she loses her rudder. And I think, to paraphrase Oscar Wilde, to lose one rudder is unfortunate, to lose two feels careless. But again, survives it. But here she is with this really beautiful sleek hull. One of the things that is really important about the restoration of the Cutty Sark, a big risk was taken to lift her like this. Now, we can argue about whether that's good for the ship or not, but ultimately the thing that's really good for it is that the public get to see the natural lines of the ship. It feels absolutely organic when you're under it. It feels like you're with a whale rather than a ship. It's covered in Muntz metal, which of course is an anti-fouling protection, but it looks absolutely beautiful. So if you haven't been since this was done, do come. There's a point to this slide though, and this is the point. This is what they call a diagram of a cross-block coefficient for a ship. And I'm sure many of you as yachties are very familiar with it. But you just create a shoebox or a brick shape from the dimensions of the ship, from its length, its breadth, and its depth. And then you calculate how much of that shoebox is filled by the hull form. The higher the percentage filled, the less efficient the ship is in the water. The lower the percentage filled, the more efficient the hull will be in the water. So you'll remember our images of the tankers from earlier on. A modern tanker has a cross-block coefficient, which is something in the 90s. The Cutty Sark was sub 60. When you work with the wind, you work with nature, and you work with nature in all its forms. You go with nature. You don't oppose nature. When we got the internal combustion engine, there became an arrogance and a hubris to just overcome nature, force your way through. So a modern ship is completely disrespecting, not paying any attention to the natural shape you should be in the water. There's nothing organic about it. And believe me, I consider them quite beautiful because they were my career. But nobody could look at them independently or in isolation and think that they had any aspect of beauty. There's no golden rule about them. All they're saying is, here I am. It is one of the most oppressive statements of determination to overcome the forces of nature in order to make money. All well and good. But the fact is, along the way, it's doing an enormous amount of damage. So, when we think about the Cutty Sark, we can think about what the future might look like. And this is really the reason why I think the Houdini is so important to us, because it's a touchstone to remembering how we used to do things. I think the importance of knowing your past is that without knowing your past, you can't understand your future. In the South Pacific Islanders always say that the nature of life is to walk backwards into the future. All you can see is what's behind you, and all that's coming, you have no knowledge other than through projection of what you've seen in the past. It's quite a nice image. But I also like to think of Oedipus Rex, who goes to the oracle at Delphi and is told his future. But try as he might, he can't escape it because he doesn't know his past. Thinking his parents are his natural parents, he flees them so that he doesn't kill them and marry them, and he runs straight into the arms of his natural parents and kills them and marries them. So the great escape artist, the Houdini, has been a Houdini to really help us think about, are we doing things the right way? And what are we thinking about as the future? I stole this from MAN BMW. It's just the kind of stuff they put out about fuels of the future. And you'll see on it various different alternative fuels. And you might wonder why they're choosing them. Why would anybody use ammonia as a fuel? Why would anybody use hydrogen as a fuel? Hydrogen doesn't exist on Earth as a natural element. Ammonia is created, and it's created for very specific purposes. But essentially they're batteries. They're ways of storing hydrogen in a way that can be re-exploited at a time that suits you. Hydrogen won't be a fuel that's used for big ships. Why? Because a voyage to Australia or to China and back is 13,000 miles each way, and then you have a need for autonomy on the whole voyage. How are you going to manage that with hydrogen, which has such high volume and such low density? It just doesn't deliver enough energy. So then we move on to looking at other alternatives. Ammonia created from hydrogen solely for the purpose of concentrating that energy sufficiently to be able to be carried on board a ship. Remember what I said at the beginning. You want to maximize cargo space. The last thing you want to do is to have a voluminous fuel that means that you shut out cargo space. But all of these are not really helping, because all of these all depend on exactly how you make them, because all they are is a mechanism of transference. The core value, the energy that's free, is in the sun, the wind, the water, and the earth. Those are the things that we can tap and use and harness. But if we do, does it make sense to use the ship designs that we use today? Or should we look back at the Cutty Sark and say there could be more ships? That would be okay, wouldn't it? There could be more people at sea. Well, we've got no shortage of people. But if we could save the damage that we do to the global commons, that would be really meaningful. The problem that they have today, that Manby and Double are trying to solve with this chart, and the reason that they're turning to LNG, which is a fossil fuel, or LPG, or different forms of methanol or hydrogen, all of these have been designed because they're ways that look like they're logical for powering a modern ship. But a modern ship only reached its economies of scale because of fossil fuels. It reminds me of that old joke about an American couple on holiday in Dublin. They go up to a local Irish Dubliner and they say to him, "How do we get to Trinity College?" And he says, "Well, I wouldn't start from here." If we're going to solve the problem with powering ships, we can't start with a 3 million barrel crude oil carrier. We can't start with a 24,000 TEU container ship. We have to think back and be challenging enough, to be imaginative enough, to think about how we can actually move cargo in a way that works for us. There are other problems, and I know that you're all itching for another drink, so I'm going to move through this pretty quickly. But as ships got bigger, they couldn't come into our cities. This is the upper pool, and this is not that long ago, at least for the people in this room, not that long ago. So we're looking at an image now that really ended. This image disappeared from this reach of the Thames at about 1970. That's when St Catherine Docks effectively stopped taking cargo, and we started to push further out. Of course, Tilbury already existed, and of course the bulk of London's cargo had come into Docklands, right opposite our museum. But this is how recently we had ships in the middle of the city. Why is that important? Well, it's important because everybody knew what a ship was. You went to any pub in London around here, you'd have met sailors. People would have been talking about distant ports, talking about the cargoes they carried. There would have been a connection, which meant that people wouldn't have need to ask the question, what does the word maritime mean? But as we built bigger and bigger ships, we shoved them further and further out. London's biggest ports are really Harwich and Tilbury. So this results in the public not really having any concept that 90% of everything comes by sea. The ocean now is essentially only a cultural phenomenon for most people. And for those of you, to demonstrate this, next Tuesday, underneath the Cutty Sark, they will have a live broadcast of an episode of Front Row dedicated to the shipping forecast. And when we talk about that, we at the museum will talk about its significance for shipping. But I think everyone in the audience, and the vast bulk of people listening at home, now think of it as a kind of meditative prayer or a form of evening entertainment. They no longer know really what it means or why people had it or why it was important. Because the bulk of people now have lost touch with the sea. They don't see the ocean. They don't understand its significance. They don't understand it as a machine that structures the distribution of heat on Earth, that is the source of all life. And the closest most people will get to it is really from watching David Attenborough. But shipping is cool. By the way, this is an image from a ship that picked up some sea spray on the way into Quebec. And as it picked the sea spray up, of course, it turned to ice on the deck, and eventually the ship couldn't discharge its cargo and had to come all the way out of the river and go south in order to get enough warmth up to melt the ice, because no equipment in the refinery or on the ship could deliver enough energy to melt the deck. These are the sort of stories that people used to know because they used to meet sailors in the pub. Now sailors aren't allowed off ship when they come into ports, let alone the fact that they'd be in Harwich anyway. But shipping's really important to us because, as I've said, destructive as it is, compared to other methods of transport, it's still pretty cool. So if you move, it's 1 ton of cargo moved 1 kilometre, and aeroplanes emit 500 grams of CO2. Sea freight, 10 to 40, depending on the speed and size of the ship. Road freight, 60, and rail transport, 30. So what it can tell you is that shipping is by far the most efficient way of moving goods, so we should definitely be doing more of it. I'm an advocate of doing more of it, with more ships and more sailors, and doing it in a way where we can move on those smaller ships right into the hearts of our towns and rejuvenate and save the city centres of our ancient ports from being turned into luxury flats and squash courts and gymnasiums, and get them back to having cargo handling and to get some vibrancy back into our high streets. There is a virtuous circle that could impact many aspects of our lives in a way that would be really favourable. Shipping can also be hot. This is an image of Limburg, one of our ships that was blown up by Al Qaeda in 2002 at the port of Ash-Shahir in the Yemen. Shipping has its dangers, and of course it's not for everybody. But the answer is not to make shipping autonomous. The answer is not to mechanise everything that we think is risky or dangerous. There's a great secret about life that I don't think we've really shared enough. You're all going to die. The certainty of death is there, and what's important about our lives is not how long they are, but how well lived they are. And it's as dangerous as anything to sit in front of a television set waiting for something to happen as it is to go out and be a sailor and to work at sea and to take your life in your own hands. There's much to be said for the risk involved. And as Chris can tell you, autonomous shipping may prove to be very dangerous. I don't know if many of you know about the challenges that the aircraft industry is having today with deliberate interference with geopositioning of planes, but we're creating ships which are now so much based on the technology of the machinery, creating an Internet of Things, that if you hack into it, you could control the ship. Now, the good thing about aeroplanes is that they always have a pilot on board. And by the way, never get onto one that doesn't have a pilot on board. Human understanding of navigation and time, having somebody on board who understands the principles, something we also teach at the Royal Observatory, by the way, with some excellent courses. So do speak to me afterwards if you want to go. But look, you need to make sure that the bulk of the population understand the significance of knowing where you are and what the time is. Those skills are going to become important when we come under stress. Today it's easy to forget them because you can just pick up your phone. In 1859 there was a huge solar expulsion called the Carrington event. The northern lights could be seen during the daytime in the Mediterranean, and cattle were fried for just because they were standing next to barbed wire fences in America. The telegraph was operating even without battery or power attached to it. If that happened today, it would knock out every satellite around the Earth. It's one of the reasons why one of the things that many of the space stations and other space observers are doing is watching solar weather. Because in the 8 minutes it takes for that expulsion to reach Earth, there's a chance to turn or position your satellite to minimise damage. These are all very real things that can happen. And human beings having a good understanding and shared knowledge of what you would do to understand time and position if you didn't have your phone, if you didn't have your computer, are critical. On aeroplanes everywhere now, there are pilots operationally, deliberately shutting their systems down because drones have interfered with their positioning system, have set it in the incorrect way, they've had to shut them down to reboot them during the flight and then carry on. But you need a human hand in that, and that human hand needs a good understanding. That human hand needs experience. It needs good jobs. It needs people still engaged in trades, which is why my mad idea that we would say, let's have more ships, let's have more crews, let's have less carbon in our air and our seas, is not as mad as it seems. And besides which, for some people it was a good life, and it had its good moments. And the quote there is of course from scripture, they that go down to the sea in ships, that do business in great waters, they see the works of the Lord and his wonders in the deep. Thank you.
Brilliant. Questions?
Brilliant. Thank you.
Questions?
Well, this isn't really terribly. The murder on the Cutty Sark, you've gripped my interest. What happened there?
So, it
Well,
was,
they could interest you.
it's a cracking story, and Joseph Conrad wrote a short story that was based on it because it was a cause célèbre at the time, and it was the start of a monstrous voyage that the Cutty Sark was on for 2 years, where it dawdled and dwindled from one place to another. Rather like one of those songs from the Dubliners, when they signed the crew on board, they signed on board a pretty vicious mate. And taking exception to somebody he thought was indolent and lazy, he hit him with a spar and killed him. The captain, under protest of the crew, felt obliged to lock the mate up, to hand him over to the authorities when he got to Singapore. For reasons which may have been personal, the captain let the mate out before they reached Singapore, and the mate slipped overboard and swam ashore. The captain realised that he had disgraced himself and didn't have a way back, whatever the hold the mate was over him, and so committed suicide. And a very unhappy crew were left in Singapore and hastily signed on board a captain whose major pastime was drinking rum. And they started a meandering voyage where they ran out of supplies a number of times because every time he was given money to refit the ship, too much of it was spent on booze and not enough of it was spent on victualling properly. And they had a miserable run of luck. And it took them 2 years before many of the crew were relieved when they reached their final destination of America with the cargo that they had picked up in the Far East. It's an interesting story, but Conrad's book, The Secret Sharer, is a really delightful tale about somebody, for reasons not fully explained, betraying the trust that's bestowed on him by the owner of the ship and by his crewmates.
Thank you.
I've got two questions, one totally different. One, the Cutty Sark, the original early photographs, huge amount of sail, but it's not that deep. When it's full of grain, there's weight in there. I'm not an architect.
So we always sail in ballast.
Well, so the ballast. So you said there were 14 were lost out of the Chaperone de Cutty Sark. Is that when they were full, were they unfull? Or were they selling too much? Or
It was.
the other question.
Yeah.
Completely different. you see some modern ships now with big metal sails. Is that something, you're talking about the carbon, is that something you think that that say going back to sail, as you finished your sail, gives a sail, motor, engine, diesel, or sail, steam, oil, sail, is that something you think?
So, yes, so first of all, ships in ballast, if you look at our big tankers, they have essentially they have a U-shaped structure, like a huge U-bend, and then a single flat deck. And in the U-bend they have ballast tanks. So as soon as they start discharging their oil cargo, they have to start loading water into that U-bend to keep the ship stable. And whilst they might carry, the examples I was showing you was, so a VLCC might load 300,000 tons dead weight cargo. But when it discharges that cargo, it will load 50 to 60,000 tons dead weight of water. And that gives it enough depth. The difference in the freeboard between what we might call a ballast condition and a fully laden condition might be 10 metres. So the ship looks very different when it's laden and when it's unladen, but it has enough stability for it to stay stable in seas. Because the ship has no keel.
Yeah,
the advantage of the Cutty Sark is it has something of a keel. The only keel on one of these flat-bottomed ships, essentially you create your own keel by being deep in the water, but you also have what they call a bilge keel, which is a metal fin running to give stability on the turning point of that U-bend. So that's how the ballast. With the Cutty Sark, she would have always carried cargo. So if you read Eric Newby's Last Grain Race, when the sail ships that he was on were going to move out to, and remember they were one direction with cargo only. So what they loaded was they'd come down to one of the loading points in Kent, and there they would load just hardcore. They would just have stones and rocks put in the ship, because if you didn't get weight into the ship, it couldn't take any pressure on the sail, otherwise it would flip. There's no deep keel. So. And the second question was?
Was metal sails on these huge...
Yes, no, so the modern sails, and they're not, they're rigid. I'm not sure what the composite material is, probably not metal. Yeah. But yes, so there are a couple of different ways of doing it. But first of all, they work. And you have a number of different types, and I should have got some photos for you of this. You can either have what you'd call the rigid sail that you've just described, where you would turn to catch the wind if you wanted it. Also, you can have just panels, solar panels that come up like this. Most of them have the capacity to be retracted or withdrawn in some way, so that they don't take an adverse wind. And they have a limited ability, because you don't want to be, with a modern ship, you don't want to be tacking it. You want to be able, what you're really doing is getting wind-supported assistance. And that reduces your fuel bill because you're getting a push from the wind. Yeah. So you're really just looking for, can I use the wind that's available to me now? That's one way of doing it. You can of course have solar sails as well. You can also have a kite. So you can have a really big kite sail which comes off usually off the bridge of the ship. And again, it's everything that can to give you a little bit of assistance. And the one other thing that's really much more common is a Flettner rotor. And this is essentially you have a small engine which is driving a turning motion in a long pole which has a fin down the side of it, and this sucks the air down one side faster than the other, and it creates a drag, and this pulls the ship along. The first solely operated, so the only form of propulsion was a Flettner rotor, was a ship, and I think it was called the Birkenau, and there's a lovely bit of film on YouTube that you can see with it going across Whitney Bay or somewhere in 1909. A ship sailed only by a static rotor fin blade. So that technology has been around for a very considerable period of time.
If we are going to move away from these massive ships and these big economies of scale and back towards smaller vessels that are less damaging to the environment, where do you think that change realistically has to come from? Who or what has to take the first step in sort of encouraging people away from these massive ships?
as you can imagine, I'm a great believer in market forces, as long as you structure and regulate markets. A lot of people talk about market forces where you just let everything go. But where market forces can, they're a good way of distributing resources against needs. But the shipping market that delivered all these big ships was not a free market. That was a targeted market where government subvention determined where the ships were built and how they were built. I have to say, the British had big shipbuilding capacity for one reason only. They had a very big maritime empire, and you could only sail freight within the empire if you were a British hull. So that was the subsidy that the British Empire gave to shipbuilding. But initially Japan, an island nation that was to become a huge producer, knew that it needed cheap shipping. So it focused its government into shipbuilding and into subsidised shipbuilding, which gave financial support to the shipyards, but it also gave for any of the buyers a guarantee that if the shipyard didn't deliver, they could get their money back. And the shipbuilding guarantee has been one of the ways that governments have intervened in a way that's accepted by the World Monetary Authorities as being okay, but it is a massive subsidy. And it means that ships are built in a way that's uneconomic to the shipyard, because essentially the buyer doesn't have to check that the shipyard can survive. That's being guaranteed by the state. So what I would say is that when you look at all the time from the 1970s through to the current day, Far Eastern builders, Korea, Japan, China, all had government subsidy of one sort or another. If you want to change the direction of travel, notwithstanding my great belief in the markets, the kickstart has to come through determined government, far-sighted intervention. One of the things that you could do in Britain, and if I get a chance to speak to the Minister of Shipping or Minister of Transport, it will be to make this point, is let's get lorries off the roads. Because quite frankly, small, ecologically designed tankers and container carriers particularly, container ships could carry just 3 or 4 containers if they weren't going to cost anything to move them. And if you can find a green way of propelling that ship, you could distribute cargo around Britain and get it off the roads. And if you get it off the roads, wouldn't it please all of us drivers? Or in future cyclists, of course. But it's just that there are some real wins, and I don't think it has to be that difficult. You don't have to solve every problem, because really you just have to seed the trend.
I think it's absolutely fascinating in this talk, because we've actually gone through all the economics of where we are and how we've got there as well. What do you see as being the future? You know, so you've hinted at it. Where should we be going as a nation?
So I think. Let me give you, I don't want to sound like I'm evading the question, but I am evading the question. There is a real struggle there. And the struggle can probably best be captured by the expression, by the concept of carbon capture. I don't think there's anybody who doesn't understand the problem that we've got. Now, many people would just want to look away and they shut an eye. And some people will pretend that there is a system of carbon capture that can be used. And why? It's because there is a massive infrastructure in oil and in coal. And if you were to turn your backs on them, then there is a huge problem with stranded assets, which is why Saudi Arabia said that they wouldn't sign COP if there was going to be a penalisation of crude oil. But we know what we're doing. We're taking years and years and years of carbon, which has been effectively captured by plant life and sunk, and we're flaring it back up into the atmosphere so that we can drive faster. Now that's a problem we've got to resolve. So the question for somebody like the UK, which doesn't have a huge amount of stranded assets, actually what we're doing is constantly subsidising other people's stranded asset problem by not addressing the green issue. If we can turn our attention to this in a way that's effective, then we need to get on with it. But we have to be very careful about not making mistakes. Lime bikes, battery operated bikes for hire are a mistake. People need to get on a bike that's a normal bike because it's good for them health-wise, at the same time as meeting our green agenda. The sunk cost in a lime bike is not going to make the difference. You will not recapture the sunk cost of making that bike compared to getting on a bus. So there are lots of little false starts that you can make. The hybrid car is a disaster. You'd be better off taking a petrol car and driving it to an absolute end of life. Because the sunk cost in this really heavy equipment that you build is far more damaging than the saving that you think you're going to make from shifting the technology. But they're seen as ways of feeding public mentality, feeding the public's desire for feeling that they're doing good or making a change. I think that I don't really have a short answer to it, but my long answer is that we need to have a better infrastructure for understanding the problem. And that's why I think museums have a really important role in this. I think there are stories that we can tell, which if we tell them in the right way, will go home better, and people will understand the extent of the problem. This isn't going to be easy. There isn't an easy answer. And anyone who thinks there is mistaken. But localization, and we can see it coming anyway, that you think about the way we've been living our lives for the last 20 years. Maersk used to advertise that one of their 24,000 TEU container ships could carry enough training shoes to give one pair to every member of the population of Mexico. I mean, that's bonkers capacity, right? It just gives you an idea of how overcapacitated we are, how too much capacity. And why would you make things in China, a country which isn't rich in resources, and ship them abroad? You have to ship in and then you have to ship out. Well, because they were coming out of a state of high education from a communist regime and moving into a less communist regime. I don't know, some form of totalitarian regime, but let's say less communist. But along the way, the population has shrunk and is on a course to continue to shrink. China will not be the production centre of the rest of the world. But in the meantime, we've built an infrastructure which seems to expect them to continue indefinitely being the production centre for the world. So we've done some very strange things. These may well come to our rescue. We should build locally. We should eat local food. We should eat less meat. But again, I have young adult children, and drinking oat milk and eating avocado is not going to solve this problem if you still go on holiday to India.
Fly avocado in.
650 grams of carbon per kilo moved compared to 40 or 10 by ship. Maybe we should go on sailing holidays.
We do, quite right. Actually, that's probably a good note to end on. Sustainable debates, we could probably go on for hours.
Absolutely fascinating.
It's brilliant. Paddy, thank you so much.
You're welcome.
That was a tour de force.
It was a tour of my life. No, look, I really enjoyed it, and thank you. You've been really, really delightful audience. So nobody threw anything, and there was no booing. And
Well, the stunned silence with this.
well, Dennis looked like he was sucking lemons when I was talking about stopping the oil trade.
I haven't asked a question, Paddy.
I can also see why you're natural to be director of the National Maritime Museum.
Thank you very much.
Fantastic.
Thank you.
And a round of applause. Right, the bar is open.